Go. So notes out, you got it, you got it. Attention up here, please. Let's get rolling. Okay, so somebody tell me now, we've got some important vocabulary we want to sort out here. We're gonna work towards, so today what I want you to do, here's kind of the expectation. I want to refresh your memories about the definitions of a relation and a function. And then we want to start to talk about inverse functions. Okay, what's unique about, inverse relations and which of those, how do we define an inverse relation? What's it mean graphically? And then how do we specify which inverse relations end up being inverse functions? That's a lot to do in a short day, so that's the goal. We'll see what we can get through. So what's a relation in math? And these are really important words. I want to make sure we get this. I don't have to get it exact. Just kind of tell me what is, in your own words, what is a relation? Going back to past years. We've mentioned it in here this year, but not much. I mean, think back how it was born. What's a relation do? Tell you what, I'll give you a definition and you explain it to me. Let's go that way instead. Any pairing of elements of the domain with elements of the range. So what could a relation look like? Could be a function, sure. It could be a function. It could be something like f of x equals 3x minus 5, right? It could be a non-function. It could be something like x squared plus y squared equals 4. If I graph that, can anybody tell me what that looks like? It looks like a circle centered on the origin with radius 2. Okay. Talk more about that later in here, actually. This way of describing a circle. It could be either of the two. It might just be a relationship between two sets. It might just be something like maybe I've got something like that. So what's the domain in this set? What is it again? Yeah, 1, 2, 3. Okay, what's the range? 2, 3, 4. But we know more than that because this is a relation because we are specifically mapping or pairing elements of the domain to elements of the range, right? So in this case, we know that 1 is mapped to 2. Does that make sense? 2 is mapped to 3, and the element of the domain 3 is mapped to the element of the range 4. Okay, so it could be any of that stuff. It's just any way that we're going to define a pairing of elements of the domain with elements of the range. A lot of times that's going to look like a mapping, and we'll see a couple examples of that soon. Okay, now, this I know you can answer. So given that a relation is any kind of pairing of the domain to the range, what subset of that is called a function? And once again, just in your own words, only certain special relations we can call functions. What's the additional rule there? Yes, sir.
A relation where
Sorry?
Where x doesn't have two different values on the same x.
No, you're right. For every input value of x,
Something different.
there's going to be, there's only one output, right? For every input, there's only one output. This is what you were getting at, I'm sure. Okay. Okay, so exactly one element of, there's exactly, I actually wrote that wrong. For each, it should say for each element of the domain, there is exactly one element of the range. I don't know why, that was kind of an awkward way. I don't know why I wrote it that way, but let's cross this out and rewrite it. So special relation that pairs for each input, typically x, right? each input, there's exactly one output. What does that correspond to in terms of a graphical test? Remember how you can look at the graph of a function and immediately tell if it's or of a relation and tell if it's a function or not? How's that work? Remember?
Is it the one where it's like you look and see if there's any like in the same,
Okay.
like two dots in the same?
Okay, yeah, we call it the vertical line test, right? So let me see, what are these? Oh no, so. So for example, let's graph two different relations. Let's call the blue one F. And let's call the red one G. Okay, which of those, well, how many of those are functions? One. Which one? The blue one, good. And the reason being that if I do if I drag there we go. If I drag this vertical line across the board, it will only ever intersect the blue graph in one place, right? However, there are some locations where I get multiple intersections. That vertical line intersects the red graph in more than one place. And therefore, the red graph is disqualified. It fails the vertical line test, right? Now, we could say, however, are there some intervals on which the red relation could be considered a function? So where would that be, for example? So you guys are pointing left. So if I went over, tell me when to stop. Okay, so everything to the left of that point would be okay, right? So if I were just to do something like maybe, if I were just to say something like this, everything over there would be fine, for example, right? And then by the same token, maybe everything over there, if I just disqualified the stuff in the middle, right? Okay, good. This is ringing a bell? Okay, good. All right, so let's look at some different types of relations then. So a relation, remember, is it links the domain to the range in a predictable way. Maps elements of the domain to elements of the range. So here's one type. And this goes a little beyond what the book does. You might want to add this to your notes. I could even print this off. Somebody remind me, I'll print this off for you, just give you copies. I'll put it on the Moodle site too. Okay, so you can, it'll be there. Okay, this is called a one-to-one relation. How come? Why do you think?
Because everyone has another one.
Yeah, because each one element of the domain is linked to one element of the range and vice versa, right? There's only one arrow that would go from A to B or from B to A, right? Does that make sense? Okay, so that's one-to-one. This is called let's do this one first. Okay, this is called a many-to-one relation. How come? Why is that many-to-one?
Because two things go to one point.
Okay, because there's at least one instance where more than one element of the domain is mapped to a single element of the range, right? Does that make sense? But there are no instances where more than one element of the range is mapped to a single element of the domain, right? It only goes one way on this, in other words. Everybody see that? Okay. Is a one-to-one relation a function? It is, for sure, right? Okay, now, look at this carefully. Is a many-to-one relation a function? and I'll tell you right now, it's never, the answer is not sometimes. It's either yes, always, or no, never. Which one?
Never.
I'm here to vote for never. Anybody want to do something different with that? Always. Okay. How come? Because I sounded like I was pushing you that way. Now, let's think back to what the definition of a function is, right? A function is a relation for which each input value produces only one output value. Sam?
Because, like, even though, like, some x values have the same y value, they have their own.
Good. Okay. How could you maybe look at just the arrow portion of the mapping and say, okay, yeah, this is a function because
Each x has its own y.
each x only has one arrow leaving it, right? So it has to be a function. If I plug in x equals 2, how many y values is that mapped to? 1. And it's that way for each of these 5 elements, right? Each of them is only paired with one output value. Now, are there separate x values that just happen to be paired to the same y value? Sure, but that's okay, right? As far as a function is concerned, okay? What would be the graphical manifestation of that idea of a many-to-one? What are you going to see? Let's look at a one-to-one graph versus a many-to-one graph. And I want you to kind of tell me what's going to be unique about both of those. What distinguishes one from the other? Okay, so here's the blue one is going to be, call it F, and that's one-to-one. Give me an example of a one-to-one function.
X. Y equals X.
Okay, so a line, right? Y equals X. Okay, good. Now, can anybody give me an example of a many-to-one function? X squared. Okay, so that's y equals x squared, and that's many to 1. What about the red graph when we look at it? It tells us that it's many to 1. What do you think? Yes?
Different x values have the same y.
Okay, good. So it tells us, if we look at this in terms of a horizontal line, right? If I pick a horizontal line up here, I can draw at least one horizontal line where different x values, let's just call that x1 and call this x2, have the same output value. But it is still a function, right? Because it passes the vertical line test. Okay? Good? All right. So now what about a one-to-many relation? What do you think that's going to be? What do you think? Gabe, what do you think a one-to-many relation is going to look like when I pull down the screen there?
It'll be, x values will have multiple y values.
X values will have multiple y values. Good. Okay. Is this a function?
No.
It's not, right? Because now it violates the definition of a function. It works for 3. Right, if I input a value of 3, I only get one arrow leaving that, I only get one output. But what's the problem with, for example, an input value of 1? Yeah, I'm getting 2 output values. Well, isn't that by definition, if I were to graph this relation, going to violate the vertical line test? Think what that says. That means that the points, I'm going to have 2 points with x values of 1. One of them is going to have a y value of 2, and the other one's going to be vertically above it with a y value of 3, right? So that is a non-function, okay? All right, and then the last one, what do you suppose that's going to be? Many to many, yeah, where we have elements of the domain and the range which each have multiple links to the other set. Does that make sense? So for example, the element of the domain that's 1 is linked to 2 separate elements of the range, but the element A of the range is also linked to 2 separate elements of the domain. Okay? So is that going to be a function? It's not going to be, and the reason it's not going to be is because it includes which of the 3 up here are a part of this or a subset of this? One to many. Yeah. A many-to-many relation includes one-to-many and many-to-one relations, both, and possibly some one-to-one relations, too. Okay? All right, so, you want to go back?
Yes.
Okay.
Okay, why does it say many to one many?
Because I screwed it up. So it's supposed to be many to many. There you go. Sorry. Okay? Okay, so now let's move on to an inverse relation. This is a new idea. So a relation we know is just any pairing between the domain and the range. An inverse relation does something specific. An inverse relation reverses the pairing of the relation. Okay? So now think what that means. Thank you. If an inverse, or if a relation pairs the domain specific elements, which we're going to call the domain, with other specific elements that we call the range, then if I take its inverse, what does that do? Yeah, I heard it just flips them around, right? That's it. It just takes the elements that were called the domain, and they're going to become the range of the inverse. And what was the range of the relation becomes the domain of the inverse, right? That's all it does, and that's important to remember. That's all an inverse is. It just reverses the elements of the, switches the elements of the domain and the range. Sometimes people get confused about inverses, and they think there's some kind of, there's a lot going on. There's not. That's it. That's all they are. Okay, so for example, if the left pairing is considered to be the function, then the right pairing literally just swaps the sets. That's it. Okay? Make sense? All right, so what I want you to think about then is if the original relation is a function, okay, let's look at some of the things that can happen. Would you agree that this is a function on the left? So everything, I'm looking at this stuff right over here. That is a function, right? How would we describe that relation that is a function here? It's many to one, isn't it? Because it's got at least one case where 2 input elements are mapped to the same output element. But that's okay, because each input still only has 1 arrow leaving it, right? Okay, but if I invert that relation, that is a function, look what I get. I want you to fill in the blanks. So the element of the domain of the inverse, -2, is then mapped to -4, right? The element -3 would be mapped to what element of the range? 0, okay? The element 2 would be mapped to both, what? 1 and 4. So is the inverse a function? It's not, is it? Okay? It's not. Now, what if it had started off as a 1-to-1 function? Would its inverse have been a function then?
Yes.
It would have for sure, right? Because that would have guaranteed that there would have only been 1 arrow connecting each element of the domain with each element of the range. Okay? Now, if we go back to our picture, what are the characteristics of any 1-to-1 function? Here's where I want you to make a prediction now about what type of a function, just by looking at it, is going to have an inverse function. For what types of relations, for what types of functions will the inverse also be a function? Okay. we could go back here and look at this for a second, and you could probably make a prediction. Let's put a green check by all the sets that are going to have inverses that are functions, right? And a red X by all the functions, or all the categories that are either not functions or won't have inverse functions. What about the first one? Okay, that gets the green check. It's gonna have, it is a function, and its inverse is also gonna be a function. Okay, so we'll do this, green check, green check. Starts off a function, ends up a function. What about many to one? Green check, red X. Starts off a function, but the inverse is not. Okay, what about down here? Okay, so I get red X, green check, because it doesn't start off a function, but its inverse is a function. And then down here, red X, red X. Okay, so then, now let's go back to this picture. So what do you see? So, so the blue is a 1-to-1, right? Okay. The red is a many-to-one. What might be an example of a one-to-many relation? Wouldn't be a line. What about, I'm just gonna put one up here. What about a sideways parabola? Okay. And this one, by the way, I didn't draw that super well. What if it had gone through the origin? Then its equation would have been x equals y squared, and that's 1 to many. Okay, and then the last one, a many to many, let's just make that a circle. So the pink one, x squared plus y squared equals 4, many to many. Okay, so now folks, here's where, this is big, right here. This is, we get this covers a lot of ground. So I want you to make a prediction and see if you can come up with maybe even a visual test that's gonna predict how we could know if something starts off a function and has an inverse that's also a function. Right? So we could immediately disqualify the pink and the green because they don't even start off as functions, right? But of the two that do start off as functions, why does the blue work and the red not? Okay, but how can you tell? By looking at it, I heard that's really, she articulated a good way of thinking about this because the blue is 1 to 1 and the red is not. But what about the red one tells you? What about the red graph tells you that it's not 1 to 1? Say it again? Like a horizontal line test, exactly. It's like a horizontal line test. Because what do you suppose if I were to graph the inverse of the red function, which I'm going to show you how to do in a second. What do you suppose, what test do you think that red graph, when I graph its inverse, what test is it going to fail? The vertical line test. Doesn't that make sense? Because think about what a horizontal line test would say. A horizontal line test just says, okay, it is a function, but we know that in at least one case, we're going to get two separate x values that map to the same y value. Because think of what the equation of a horizontal line is. It's just y equals a constant, right? Now don't forget what that means, because it's never really talked about using this language before probably today. But if we talk about, let's just say that this horizontal line has the equation y equals 7. Okay, what does that imply about the x's? Say it again. X, okay, it's not included in the equation, and so there is no constraint on the x's, right? What does the word constraint mean in math, or in anything? If you're constrained, maybe you're doing, okay, that was good, say that again. It's a restriction, right? If you're constrained by being in a room, then that means you're limited to that room, you can't go someplace else, right? In math, a constraint is a limitation, right? So if I write down, let's just say the equation of this blue line right here is y equals x. Okay, now, the x and the y, they are constrained, but they're constrained by this equation. X, the domain is infinite, the range is infinite, but there's a specific pairing between those two. It tells us that for a given x value, there is only one y value predicted by this equation, right? Does that make sense? So the x and the y are linked. Okay, what about over here? For this equation right here, it says y equals 7, so it's constraining the y value to always be 7, but the x isn't even included. So that means there are no constraints on the x. And so there's this subtle implication here. It tells us that if the x doesn't even show up in the equation, x could be anything, right? Does that make sense? And so then we see with this horizontal line that I know that if y equals 7, x could be any possible value, right? And so if that horizontal line is intersecting my function in more than one place, right, then that guarantees I'm going to have at least one instance where multiple x values generate one single y value. And if we go back to our set, right here, wouldn't you agree that, God, I got to get this done. Wouldn't you agree that these two right here are the inverses of each other? Right? Does that make sense? And so if we start off with a one-to-many or a many-to-one, when I flip the domain in the range, I'm going to get the other, right? And we said this one is not a function. Right? Okay, we'll pick this up. I'll put the assignment up. You can get started.
Ryan,